Hi, we're here in Brooklyn, New York, once again. We're here today to talk with Francis Bitonti. Francis is world famous for being one of the first people to print a dress using 3D printing technology. We're going to talk to Francis about this dress, and about the cool projects that he's working on now in the 3D printing domain. Let's go see if we can find him. Come on in. Well, good morning, Francis. Thank you for taking the time to meet with us today.
Yeah, my pleasure. Great meeting with you.
Can you tell us a bit about your 3D printing story, how you became interested in this technology?
Sure. So I started as an architect, and well, I was an architect that was displaced. I was working as an industrial designer at the time, and we were using it for prototyping. And it was just sort of one of these like aha moments when we got a prototype back. Like it had similar mechanical structural properties to what we were getting out of injection molding, but I got it without tooling. I got it really fast, and and we were able to do things that I couldn't do, through molding. So I just became really fascinated with it after that, and I had this kind of dream in my head that it could be a manufacturing tool. I still consider what I do pretty close to industrial design. The way that we have to think about projects is much closer to how an industrial designer might think than a fashion designer, because we're not really working with fabrics. We're making things soft, but a lot of the materials we start with are not, they're not in the realm of textiles. We learn from textiles, but I don't think the kinds of materials and what we end up with and the assembly processes have very much to do with what fashion designers deal with. So I'm reluctant to kind of call myself that. Most of what we work on gets on someone's body, so it's fashion in that respect. But from a materials design sort of standpoint, I would consider the expertise of the studio to be more towards industrial design. I don't think it was the first 3D printed dress. It was one of the first that was, articulated and flexible, and it had a lot of features that were unique at the time, but I don't think it was the actual first.
Well, one of the first.
It was one of the first, yeah, it's definitely one of the first.
Well, it's not something that we see every day.
No.
And most people don't have one in their wardrobe, I would imagine.
I don't think so, no, that was an expensive dress. It's very similar to how you would design a dress normally. I think the big difference is with 3D printing, you're tasked with designing your own material. On that dress, we had to design all these little articulated joints, and then we had to come up with a way to manage, I think there was 3,000 unique articulated joints in there. So it was we started at a very small scale, and then we made methods for applying that to something larger.
So all of those 3,000 pieces were 3D printed?
Yes.
And how long did that take?
The printing wasn't that long. I think they printed the whole dress in about 2 days.
Oh, really?
Yeah.
That's amazing.
Yeah. It took longer, I think, to kind of polish it and glue crystals on than it did to print it, yeah. A lot. I think this is probably one of the things that needs to be resolved in the industry the most. We've got a lot of CAD packages, and I think the reason for that is they're all kind of good at something else, and we've sort of cobbled together workflows that make sense for what we're doing. There's a gap right now, and I think a lot of the software you would use for industrial designers that might have used in the past, they're designed for machining. With 3D printing, you're dealing with parts that are low volume, high surface area. When you're machining stuff, you usually get low surface area, high volume, because you're given standard blocks of material, and a lot of it's subtractive. So the tools are designed for that, and I don't really think we have much out there right now in the way of design tools that are I think that makes sense the way you would design for an additive process. It's a lot of thermoplastics. That's kind of the majority of what we work with. I see a distant future with organic materials, but I don't know if I see a very near future. We've been putting a lot of energy into looking at elastomeric materials, things like that, because I think we were looking at cellular structures, assembling lots of small rigid components. And I think that's just good. That's inherently limited. So I think on the wearable technology side, there's an advantage to that, because if you're dealing with polymers, you can have embedded electronic sensors, things like that. I think there's a multi-material proposition there, and there's an advantage to having elastic materials that can address the body. So I think that's going to be a huge value add for 3D printing on the fashion and textiles front. On the other side, like I think we've been seeing a lot of shoes, and that makes a lot of sense because we are working with plastics right now. Like I think midsoles, outsoles, insoles, all that stuff. Like they're complex geometry. The sizing's complicated. It's never really been solved well. I think the way we make shoes has been, it's made customization difficult. That's $1 million, well, more than $1 million question. I guess like the things I could say for sure is I think you're going to have an increase in the amount of desktop technologies that are available. Like I definitely see things going like smaller, faster, cheaper already. In spite of, I think, what a lot of the public has seen as a frustration that like it's not doing that. I think it absolutely is, and I think just hardware gets there a lot slower than software. And I think within 5 years you'll completely see that happening. I think there'll be an incentive to start selling files or maybe print at home for certain things. I mean, the print at home thing is still very questionable to me and what role that might play in someone's house. I don't think it's going to be like the replicator from Star Trek. I think it might be sort of like something you'd have in your tool shop. I think the cost of machines and materials is coming down. They're going to get more competitive, and that's going to open up a lot of opportunities, but it's hard to pinpoint exactly what. Scanning's only as good as the tools you have to analyze the scan. It's a lot of data, and I find we don't really use scanning all that much without working with someone who has some software to process that scan. Like we've done a lot of work with shoes recently, and there's this kind of idea, oh, I'm going to scan my foot and then use the foot to build the model. But there's a relationship between the form of the product and the thing that goes on your body, and it's not a one-to-one relationship. So like we really need software to process scans in a meaningful way. I think if you've ever made something like or have been involved with working with the kinds of materials that 3D printers can and the kinds of things you can get out of it, it's mind-blowing right away because you're not operating industrial scale. These machines are really small. They're basically portable. You're taking something that's really always been very inaccessible, and it is accessible. I mean, it's not easy yet, but we can very easily see that it will be easy. And that's a game changer because that's going to let you build a manufacturing infrastructure that's going to look very, very different than what we have now. It takes a long time to get hardware to market, and like you see this a lot when you look at startups, like software startups. You'll hear they've got funding, and then they're to market, and then a hardware company comes out, and it's usually a year later before that product ships. Right, so you're already just starting at this much slower rate of evolution, and there were a lot of patents that I think prevented healthy competition, especially around things like materials, that really kind of kept costs super high and sort of kept it in this realm of being exclusive to prototyping. That happened with FDM. Like there's a lot of stuff going on with FDM, and I find FDM really exciting right now. And it's been in the public domain a while. We've had a chance to let people iterate and innovate, and now it's mature. So as we're starting to see a lot of these patents run out, you're going to see that same thing happen. And I think the rate of innovation will increase. Our website's a good place. Social media, we post a lot. Actually, social media is probably better than the website. I don't update the website that much. So.
And the social media site, what would our learners type in to find?
Just my name, Francis Bitonti, Twitter, Facebook.
Thank you for your time.
Cool, thanks so much.
Thank you. I appreciate it.